Hello, hi everyone. Welcome to the Student the Brand. This is our Sivasa. Today topic is electric current. Electric current is nothing but the rate of flow of charge. Rate of flow of charge is called electric current. I equal to Q by T. I equal to Q by T. SI unit of current is ampere. SI unit of charge is coulomb. SI unit of time is second. Rate of flow of charge is called electric current. Rate of flow of charge is called electric current. I equal to Q by T. I equal to Q by T. SI unit of current is ampere. SI unit of charge is coulomb. SI unit of time is second. 1 ampere is defined as 1 coulomb of charge flowing through unit cross-section area per second. SI unit of current is defined as 1 coulomb of charge flowing through unit cross-section area per second is called electric current. I equal to Q by T. I equal to Q by T. Yes or no? Yes or no? Yes or no? Yes or no? I equal to Q by T. 1 current. 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 Yes. So 1 ampere is defined as 1 ampere is defined as 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. I equal to Q by T. I equal to Q by T. SI unit of current is ampere. SI unit of charge is coulomb. SI unit of time is second. Second, 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. Per second, yes. So that is about electric current. Now we can see, so charges, if you are taking the conductor, this is the conductor. So if will you say only one electron flows? Yeah, yes. So 1 ampere of current is 1 ampere. So in 1 coulomb, so 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. So now one thing I will say, if only 1 electron flows, will you say current is flowing? Only 2 electrons flows, will you say current is flowing? So we can't say only 1 or 2 electrons flows, so current is flowing. So there are many charges, are moving in the conductor. There are many charges are moving in the conductor, then only we can say current is flowing. Then only we can say current is flowing. Yes or no? So here you can say in 1 coulomb, so 1 electron, 2 electrons, 3 electrons, 4 electrons, 5 electrons, 6 electrons, number of charges are moving. So then we can say Q equal to plus or minus Ne. Sir, why you are taking plus or minus Ne? Why can't you take only positive charge? No, so there are charges are moving, right? Charges are moving. Okay, so number of charges are moving in the conductor. Number of charges are moving in the conductor. Yes or no? Same. Number of charges are moving in the conductor. Q equal to Ne on 1 electrons. On 1 electron, how much charge is flowing? Will you say? On 1 electron, how much charge is flowing? So on 1 electron, how much charge is present? On 1 electron, how much charge is present? On 1 electron, 1.6 into 1.6 into 10 power minus 19 coulomb. On 1 electron, on 1 electron, 1.6 into 10 power minus 19 coulomb. In 1 coulomb, how many electrons are present? In 1 coulomb, how many electrons are present? Can you say me? Can you say me how many electrons are present in 1 coulomb? In 1 coulomb, how many electrons are present? In 1 coulomb. So in 1 coulomb, 1 coulomb, 1 by 1.6 into 10 power minus 10 power 19. 1 by 1.6 how much? 1 by 1.6 how much, can you say me? 1 by 1.6, 0.625 into 10 power 19. 0.625 into 10 power 19. So we can take 6.25 into 10 power 18 electrons. In 1 coulomb, in 1 coulomb, 6.25 into 10 power 18 electrons are present. Yes. So electric current, the rate of flow of charge is called electric current. I equal to Q by T. I equal to Q by T. 1 ampere, SI unit of current is ampere. So normally we can write small letter. So we can write SI unit of current is ampere. And honoring the scientist, we are writing coulomb. Coulomb and time is second. So on 1 ampere equal to 1 coulomb of charge flowing through unit cross section area per second. Yes. I equal to Q by T. I equal to Q by T. Yes, in 1 coulomb, how many electrons are present? 6.25 into 10 power 18 electrons are present in 1 coulomb. In 1 coulomb, 6.25 into 10 power 18 electrons are present. On 1 electron, how much charge is present? On 1 electron, how much charge is present? Can you say me? On 1 electron, how much charge is present? On 1 electron, 1.6 into 10 power minus 19 coulomb. On 1 electron, that much charge is present. Keep in mind, very important. I am saying to you only, very important. 1.6 into 10 power minus 19 coulomb. In 1 coulomb, how many electrons are present? 6.25 into 10 power 18 electrons. 10 power 18 electrons. Yes, understood? So this is about electric current. SI unit of electric current, ampere. SI unit of charge is coulomb. SI unit of time is second. 1 ampere equal to 1 coulomb of charge flowing through unit cross section area per second. Will you say current? Only 1 electron flows. Will you say current is flowing? Only 2 electrons flows, will you say current is flowing? Only 3 electrons flows, will you say current is flowing? No, we can't say like that. There are many charges, many electrons are flowing in the conductor. Then only you can say current is flowing. Yes. That is nothing but quantization of charge. What is that? Quantization of charge. What is quantization of charge? So in a conductor, okay, so number of charges are moving, number of charges are flowing, number of charges are moving inside of the conductor. Yes sir, number of charges are moving, then only we can say current is flowing. So when you on switch, immediately we can able to see the bulb is glowing. Yes sir, no? So if you on switch, like it's like a flash, it won't happen, right? So already in the conductor, electrons will be present, so the energy will be okay. So that's why immediately when you on the switch, automatically current, the bulb is glowing. Yes or no? So that's why now where we are. Yes. So in 1 coulomb, how many electrons are present? 6.25 into 10 power 18 electrons. On 1 electron, how much charge is present? 1.6 into 10 power minus 19. On 1 electron, how much charge is present? On 1 electron, how much charge is present? On 1 electron, 1.6 into 10 power minus 19 coulomb. That is a charge on 1 electron. Charge on 1 electron. What about in 1 coulomb, how many electrons are present? Can you say in 1 coulomb, how many electrons are present? In 1 coulomb, how many electrons are present? 6.25 into 10 power 18 electrons. Are you understanding or not? How much important it is? Very important. Very important. Okay, so keep in mind. So 1 mark question expected from here. So 1 mark question can be expected from the definition, and 1 mark can be expected from here, And they will ask about define SI unit of electric current. This one, define SI unit of electric current. 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second is called 1 ampere. So Q equal to Ne, actually plus or minus, so minus sign will be taken for the electron, plus sign will be taken for proton. Positive charge, yes. So now here, so these are the points. Are you understanding or not? Are you listening or not? Are you listening or not? Are you listening or not? Yes. So if you are there, just click on like button, right? So I can feel your presence. Your presence is very, very important, valuable to me. So please click on like button if you are there in the class. And if you are listening my words, just click on like button. Okay, so that is about electric current. So charge, everything is completed. Now, electrical elements. What are the electrical elements? Come on, everybody. Electrical elements. Cell, battery, open switch, closed switch, resistor, rheostat, ammeter, voltmeter, and wire joining, wire crossing, and bulb. Okay. So here you can see first one is cell. Cell, I am taking this as cell, positive terminal, negative terminal. Second one is bulb. Bulb, I am considering this is a bulb. Sorry. This is cell, battery. This is a battery. Cell, battery, open switch, open switch, open switch, open switch, open switch. So everybody click on like button, please. Your attendance is very, very important, valuable. Your presence is very valuable to me. So please click on like button if you are there. Just if you are watching this channel, if you are watching this live, click on like button. So it will reach to the remaining students also. They will also get benefited by watching, by observing, by joining, by listening the class. Yes. So open switch and coming to the closer switch, closer switch, closer switch. Closed switch. Closed switch. Cell, battery, open switch, close switch. Next one. Resistor. Resistor. Resistor, 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 resistor. Next one, rheostat, 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 rheostat. Next. So ready, be ready. Cell, battery, open switch, closed switch, resistor. Resistor is nothing but resistor. Do you know what do you mean by resistor? And what do you mean by resistance? Resistor is nothing but the device which is used to oppose the electric current. Device. What is that? Device. So what is the resistance? Resistance is nothing but the phenomena of opposing the electric current. The phenomena of opposing the electric current is called resistance. The device which is used to oppose the electric current is called resistor. What is the SI unit of resistance? Do you know? Do you know the SI unit of resistance? SI unit of resistance is ohm. Yes. SI unit of resistance is ohm. And the symbol for resistance. Do you know the symbol for resistance? Ohm. Very, very important. Yes. Very, very important. Symbol for resistance. Ohm. Symbol for SI unit of resistance, that is nothing but ohm. Yes. Are you understanding or not? Are you listening or not? Once again, just check once. So SI unit of resistance is ohm. Okay, na? Resistance, there are 3 points are there. Very, very important. 3 points. 3 points. These are 4, but 3 points. Okay. So 3 points. Point number 1, resistor. Resistor. Second one, resistance. So do like, share and subscribe to Student the Brand. So and resistance. So ohm, SI unit of resistance is ohm. SI unit of resistance is ohm. And fourth one is symbol for resistance. So do like, share and subscribe to Student the Brand. Yes, so you are here to listen the class. So I am very happy. I am very happy for you all. So you are attending this extraordinary, marvelous, emerging element, like so you can bring all the words to describe the class, but still I can say one thing: wonderful class. So just attend the class, click on like button, share and subscribe by the channel, so you won't miss outstanding explanation from me of CBSE Grade-10 physics. Okay, so now here what we are discussing: resistor. Resistor is a device. Resistor is a device which is used to oppose the electric current. Resistance is a phenomenon of opposing the electric current. And SI unit of resistance is ohm. And the symbol for resistance is this one. So this is the symbol for resistance. Okay, so this is the symbol for resistance. Is it clear? So these are the electrical elements. So now rheostat. So rheostat is a device. Do you know what is rheostat? Rheostat. What is rheostat? Rheostat is a device which is used to oppose the electric current. That is a resistor. Resistor is a device which is used to oppose the electric current in the circuit. Right? But what is rheostat? Rheostat is a device which is used to regulate the current. Rheostat is a device which is used to regulate the current without changing the voltage source. So without changing the voltage source, we can regulate the current. Without changing the voltage source, we can regulate the current. That is what is that device? Rheostat. What is that device? Rheostat. Yes or no? What is that device? Rheostat. Yes. And coming to ammeter. What is ammeter? Ammeter is a device which is used to measure the electric current in the circuit. Ammeter is a device which is used to measure the electric current in the circuit. What is a voltmeter? Oh my god. What is voltmeter? Voltmeter is a device which is used to measure the potential difference. Voltmeter is a device which is used to measure the potential difference. Ammeter is a device which is used to measure the current. Voltmeter is a device which is used to measure the potential difference. Oh my god, how ammeter will be connected in the circuit? Ammeter will be connected in series combination. Yes, ammeter will be connected in series combination. How voltmeter will be connected? Voltmeter will be connected in parallel combination. Ammeter will be connected in series combination. Voltmeter will be connected in parallel combination. Now we will see the symbols for those two. Wow, very nice. Amazing. Ammeter symbol, this is ammeter symbol. Ammeter. So next one, voltmeter. Positive to ammeter is a device which is used to measure the electric current. Voltmeter is a device which is used to measure the potential difference. Wire joining. Next, wire crossing, wire crossing. Next, 11th one is bulb, 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 bulb. So these are electrical elements, electrical elements. Cell, battery, open switch, close switch, resistor, rheostat, ammeter, voltmeter, wire joining, wire crossing. But these are electrical elements, electrical elements. Now we are going to discuss about electric circuit. Sir, what is electric circuit? What is electric circuit? Oh, sir, electric circuit, sir. Just now or yesterday only I read, sir. Sir, just now only I read, sir. Sir, I just now practiced, sir. Oh my God. So I wrote tested in the test. Oh, ma. So many times I read that concept. Oh, babo, oh, ma. I read so many times. I practiced many times. I'm not getting electric circuit where it is. Oh my God. Electric current? Electric current is nothing but SI unit of electric current is ampere. SI unit of charge is coulomb. And SI unit of time is second. But no, electric current, electric current, what is electric current? What is electric current? Oh, rate of flow of charge is called electric current. But what about electric circuit? Oh, electric circuit. Oh my God. Electric circuit. A continuous and closed path of an electric current is known as an electric circuit. What is electric current? What is electric current? What is electric circuit? Electric circuit. Electric circuit. Electric circuit. Electric circuit. What is electric circuit? A continuous and closed path of an electric current is known as an electric circuit. A continuous and closed path of an electric current. A continuous and closed path of an electric current. A closed and continuous path of an electric current is known as an electric circuit. A closed and continuous path of an electric current is known as an electric circuit. How to draw the electrical circuit? So we know bulb symbol. Yes or no? You know the bulb symbol. You know the switch. You know the battery. And you know how to connect all those things. Shall we draw the electric circuit? Yes. So I am drawing battery. So this is the battery and the switch. And now this is the bulb symbol. Yes, bulb symbol. So I'm connecting all those things. Yes or no? Yes. Okay. So do you know one thing? Current will pass from positive terminal to negative terminal to positive terminal. Here there are 2 points. Oh my God. Here there are 2 points again. Conventional current and electric current. Conventional current and electric current. Conventional current is nothing but, so the flow of positive charges is called conventional current. Electric current is nothing but the flow of electrons are known as electric current. So now you can see here. So positive charges are moving from positive terminal to negative terminal. So what is this bulb? Glowing bulb, because we connected. So switch is closed, right? Here switch is closed. So battery is connected. If the switch is closed, battery is connected, current is flowing through the bulb, right? If the current is flowing through the bulb, it must glow, right? So you have to draw like that, because it is this symbol, it represents the bulb is glowing. The bulb is glowing. Current is passing from positive terminal to negative terminal. So here one point. So I said here 2 points we need to discuss. What are those? So here positive charges are moving from positive terminal to negative terminal. Positive charges are moving from positive terminal to negative terminal. That is called conventional current. What is that? Conventional current. Conventional current is nothing but flow of positive charges. Flow of positive charges is known as conventional current. Flow of electrons is known as electric current. Oh, yeah, 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 yeah. Positive charges are moving from positive terminal to negative terminal. Negative charges are moving from negative terminal to positive terminal. Conventional current. Conventional current. Conventional current. Conventional current. Coming to electric current. Second one, electric current. So what is conventional current? What is electric current? Conventional current is nothing but the flow of positive charges. Why you are saying conventional current and electric current only for one current only? We are getting this much. You are saying two types of current, conventional current and electric current. How can we remember? How to remember? Can you say once? How to remember? How to recognize? How to fix in our mind? Can you say that point? Here we know that electric current normally the rate of flow of charge here, but particularly here we are saying conventional current and electric current. Conventional current is nothing but positive charges, the flow of positive charges, the movement of positive charges is known as conventional current. So conventional current will move from positive terminal to negative terminal. Electric current, electric current. The flow of electrons is known as electric current. Electric current. Positive charges will move from high potential to low potential. So conventional current, positive charges will move from high potential to low potential, whereas electric current will move from low potential to high potential. Okay, sir. So you said here conventional current is nothing but flow of positive charges. Charges will move from positive terminal to negative terminal. That is called conventional current. That too, positive charges will move from high potential to low potential. So very nice, extraordinary, marvelous, amazing, mind blowing. Nice, good thing, so. But what about electric current? So electric electrons, negative charges are moving from negative terminal to positive terminal. Electrons are moving from negative terminal to positive terminal. So will it is possible to move electrons from positive terminal to negative terminal? That is not possible, because only electrons will move from low potential to high potential. That to negative terminal to positive terminal. That to low potential to high potential. So these 2 points are very, very important. Definitely one question will come on this concept. That too, conventional current and electric current. Conventional current is nothing but the flow of positive charges, that too high potential to low potential. Here is the positive terminal as high potential, negative terminal as low potential. Positive charges are moving from high potential to low potential. Electrons are moving from low potential to high potential. Okay, so this is about conventional current and electric current. So, okay, sir, you said about electric current, electric current, electrical elements, electric circuit, all these. Okay, sir. I have doubt in I have doubt in electrical potential and potential difference. So I am getting lot of confusion between electrical potential and potential difference. Can you differentiate? Can you explain the differences between those things, between those terms? Oh my God, it's really, yes, of course, it's required. So we need to discuss those points. Those are electrical potential and potential difference. Yes, very, very important. Definitely one question will come from it. Okay, so one question, definitely one question will come from it. That too, electrical potential and potential difference. Electrical potential and potential difference. Electrical potential and potential difference. Electrical potential difference will discuss first. Potential difference. Potential difference. Work done to bring unit positive charge from one point to another point within the conductor is called potential difference. Work done to bring unit positive charge from one point to another point within the conductor is called potential difference, sir. So keep it. So keep it easy way. Okay. So make it in a easy part. So I am taking this conductor. This is the conductor. This is the conductor. This is the conductor. So I am taking this is one point, and I am taking this is another point. I am taking positive charge. Positive charge. We are doing some work. Yes or no? Positive charge. I am taking one positive charge. Point A, point B within the conductor. We are doing some work to bring unit positive charge from one point to another point within the conductor. So work done to bring unit positive charge from one point to another point within the conductor is called potential difference. V equal to W by Q. V equal to W by Q. W by Q. W by Q. What is W? Work. What is Q? Charge. What is V? Potential difference. What is V? Potential difference. What is W? Work. What is Q? Charge. V equal to W by Q. Work done to bring unit positive charge from one point to another point within the conductor is called potential difference. Coming to the next one, electrical potential. Electrical potential. Electrical potential. What is electrical potential? Potential, electrical potential. We are doing work to bring unit positive charge from infinity to required field. We are doing work to bring unit positive charge from infinity to the required field. Work done to bring unit positive charge from infinity to required field is called electrical potential. Electrical potential V equal to W by Q. V equal to W by Q. Once again, everyone, to everyone. So everyone, so be ready for it. Be ready for it. Potential difference. Work done to bring unit positive charge from one point to another point within the conductor is called potential difference. W is the work, Q is the charge, V is the potential difference. V equal to W by Q. Coming to electrical potential. Electrical potential is nothing but work done to bring unit positive charge from infinity to the required field. Work done to bring unit positive charge from infinity to the required field is called electrical potential. So do like, share and subscribe to Student the Brand. Please click on like button. Just click on like button. Okay, everyone, just click on like button. Okay, so this is about potential difference, electrical potential. Now we are going to discuss about Ohm's law. Ohm's law. Shall we discuss about Ohm's law, sir? Sir, what is Ohm's law, sir? Sir, what exactly the Ohm's law? Ohm's law is nothing but Ohm's law. Work potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. Potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. V is directly proportional to I at constant temperature, and physical conditions also same. Physical conditions also same. Once again, the potential difference is directly proportional to current flowing through it at constant temperature, and physical conditions also we can say it is same. Okay, so now we will discuss about Ohm's law. Ohm's law, right? Yes, Ohm's law. Ohm's law. So here, what are the required materials? We'll see. First one, V is directly proportional to I. V equal to IR. I equal to V by R equal to V by I. V by I, V by I. Yes or no? Yes or no? Yes or no? Materials required. Materials required to do the activity. Ohm's law activity. Materials. Materials. 4 cells, 1.5 volts. 4 cells, 1.5 volts of each. Second one, nichromide. Nichromide is an alloy of nickel, chromium, manganese and iron metals. Do you know nichromide? Nichromide is an alloy of nickel, chromium, manganese and iron metals. Yes, nichromide. Hey, nichromide. Nichromide is an alloy of nickel, chromium, manganese and iron metals. What are the metals required to do the activities? 4 cells. So 1.5 volts of each. Nichromide. Next one, ammeter, voltmeter. So next one, ammeter. Ammeter. Third one is ammeter. Ammeter. Voltmeter. And fifth one is switch. And sixth one is connecting wire. Connecting wires. Connecting wires, 4 cells, 1.5 volts of each. Nichrome wire is an have nickel, chromium, manganese, and iron metals. It is an alloy. Nichrome wire is an alloy. Nichrome wire is an alloy. Very, 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 very important. Nichrome wire is an alloy of nickel, chromium, manganese, and iron metal. Ammeter, voltmeter, switch, connecting wires. These are the metals required. Now we will draw the circuit diagram. Circuit diagram. Circuit diagram. So everyone, are you listening on a circuit diagram? What is circuit diagram? Circuit diagram is nothing but, so whatever we mentioned over here, those are cells, nichromanometer, voltmeter, everything will be connected in a closed path. I mentioned how many cells? 4 cells. How many cells? 1, 2, 3, 4. How many cells are required to connect? 4 cells. So each potential difference how much? 1.5, 1.5, 1.5, 1.5 volts. So here I am connecting like here, like this. After ammeter, I am connecting ammeter. Next one. So my God, nichrome wire we have to connect. Nichrome wire. Yes, nichrome wire. Next one, switch. So here I am connecting the voltmeter. Positive terminal, negative terminal, positive terminal, negative terminal, current is flowing. So here we have to connect one by one. We should connect one by one. Click on like button, everyone. Do like, share, and subscribe to Student the Brand. Just click on like button. Just to click on like button. That's enough. That is very, very important. Okay, so here I'm connecting first 1 cell and 2 cell, 3 cell, and this is the 4th cell. So why, sir, why you are connecting with the dotted lines? Why can't you connect with the normal lines? Because when you are connecting the cells in the circuit, you are connecting one by one. Okay, so you are connecting one by one. First you have to connect 1 cell and note down the reading of ammeter and voltmeter. After that you have to connect to 2 cells and note down the reading of ammeter and voltmeter. After that you have to connect to 2 cells and note down the reading of ammeter and voltmeter. Like that you have to connect. That's why we are drawing with the dotted line. That's why we are drawing with the dotted lines. Otherwise, you could draw normal lines. Are you understanding? Oh my God. So next, now you are connecting like this. After that, so first you have to connect one cell. One cell you have to connect. And note down the reading of ammeter and voltmeter. Next, you have to connect to 2 cells. So you have to connect to 2 cells and note down the reading of ammeter and voltmeter. Next, repeat the process for 3 and 4. 3 and 4. Repeat the process for 3 and 4. Are you listening? Are you understanding? Are you there in the class? Just click on like button if you are there. Let me know you are there in the class, listening my class. So understanding my class. So I feel happy if you click on like button. Just to click on like button. If you click on like button, that is very helpful to me to reach the maximum students. Then I can teach more with more energy, with more punch power, with more powerful speech. Okay, so now we are discussing about, this is about circuit diagram. Now we are after observing ammeter reading, voltmeter reading, and mention in the tabular form given below. This is serial number of cells, ammeter reading, voltmeter reading, V by form. So when I am taking serial number. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So now you can observe here. Now you can observe here. Serial number, serial number, serial number, number of cells. Number of cells. Ammeter reading is current. Voltmeter reading is potential difference. V by equal to V by value is here you can observe V is potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it at constant temperature and physical conditions also same. Potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it at constant temperature and physical conditions also same. So that is called Ohm's law. V equal to IR, I equal to V by R equal to V by I. So see here V by equal to R. Now serial number, the number of cells, ammeter reading, voltmeter reading, V by equal to R value. Now if you draw the graph for VI, if you draw the graph for VA, V on y-axis, I on x-axis, the graph is linear. Sir, 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 what is linear, sir? Sir, why the graph is linear, sir? Sir, why can't be it is curve, sir? Here, here, here we need to understand one point, that is the conductors which obey Ohm's law, those are called ohmic conductors. The conductors which obey Ohm's law, those are called ohmic conductors. For ohmic conductor, the graph is straight line starting from origin, because ammeter, voltmeter we are connecting starting with one cell. That's why both will be at 0. That's why it is starting from origin. It is starting from origin. So V on y-axis, I on x-axis. VI graph is linear. So starting from origin. Yes or no? It is for ohmic conductors. Ohmic conductors. The conductors which obey Ohm's law, those are called ohmic conductors. The conductors which does not obey Ohm's law, those are called non-ohmic conductors. The conductor which does not obey, those are called non-ohmic conductors. The conductor which obey, those are called ohmic conductors. For ohmic conductors, the graph is straight line starting from origin. So it is like that. For non-ohmic conductor, the graph is not straight line, it is curve. So you can observe here like this. It is like this. V on y-axis, I on x-axis. So the graph is linear for ohmic conductors only. The graph is linear for ohmic conductors. The graph is curved for non-ohmic conductors. Ohmic conductors are nothing but the conductors which obey Ohm's law. Those are called ohmic conductors. The conductor which does not obey, those are called non-ohmic conductor. The conductor which does not obey, those are called non-ohmic conductors. The conductors which obey Ohm's law, those are called ohmic conductors. Ohmic conductors. Once again, we will discuss about Ohm's law. Are you ready? Are you listening? If you are listening, just click a like button. No? Remaining students can also listen this class and can get the concept. Very important concept it is. It will come for minimum 3 marks. So how it will be? So one is statement. So statement will come for 1 mark. That is nothing but Ohm's law. Ohm's law statement. So the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it at constant temperature. This question will come for 1 mark. And the second one, A circuit diagram sometimes they may give for 2 marks they may give. So draw the circuit diagram to obtain the Ohm's law graph. That is nothing but starting from origin, or a VI graph is straight line, VI graph is straight line, like that circuit diagram they will ask. After that they will ask about the graph. Draw the graph. Okay, so which will be obtained from Ohm's law. Okay, like a VI graph. Draw the VI graph for ohmic conductors, and draw the VI graph for non-ohmic conductors. Non-ohmic conductor. In MCQs also, in especially assertion and reasoning type questions, so it is very difficult to analyze and understand. Okay, so it is not that much, but once you know the concept briefly, and if you are being with the concept very clearly, so with clean observation, definitely it is very easy. That is not that much difficulty. But so you must keep in mind all these points, like so definition, V is directly proportional at a constant temperature, and materials required. After that, circuit diagrams, and next procedure. So procedure we have to connect 1 cell, 2 cells, 3 cells, and so there is a question related to this also. So they will ask about so why the graph is starting from origin, so why it is starting from origin, why we have to take from origin, like that this question related to, and the graph is linear, why it is linear, like that they will ask all these questions. Because when the current is increasing, automatically potential difference also increasing. Okay, so when the potential difference is increased across the ends of the given metallic conductor, so then current also increasing. So it varies. So it's directly proportional. So one is increasing automatically, another also increasing. One is decreasing automatically, so next one also decreasing. That is the reason. So it is directly proportional. And the line is, the graph is linear. So very, very important. So make sure that you are learning, you are preparing, you are practicing, you are keeping all these points in mind while you are attempting the assisted reasoning and MCQs, especially question and answers. Question and answers also very easy. So related to this one, problems will come, especially like a circuit diagram and this graph based questions. So draw the graph, and they will give tabular column. So this tabular column they'll ask to draw the graph, and problems also V equal to I, or I equal to V by R, and like that type of questions they will ask. And I equal to Q by T. So it's interlinked. So the formula you are taking, so V equal to IR. From I we can also write Q by T. I equal to Q by T also we can write. Q equal to NA also we can write, like that, interlinked. So interlinked, in-depth topics will be given, so especially in the question. So try to keep all the concepts, all the topics in mind while you are answering the MCQs, assessment and reasoning, and question and answers, and neatly you write. So whatever you know, so explain and write in a proper way, clear way. That must be understandable, and that must be attractive way. Okay, so that looks good. Okay, when you are attempting the questions, so keep it clear and neat and conceptual. Okay, that's enough. Okay, so this is about Ohm's law. Next we'll discuss about so do like, share and subscribe to Student Brand if you like the content, if you like the explanation, if you like the channel. So do like, share. So that gives more energy, more okay, so boost. So normally energy, okay, ability to do work is called energy. So automatically I'll get more energy, I will do more work. So please click on like button. So do like, share and subscribe to Student Brand. So it purely completely dedicated to physics. Okay, so related to physics, that too CBSE Grade-10 physics classes will be going on. Okay, so frequently. So try to click on like button, share to your friends, subscribe my channel. So inform to your friends, share to your friends as much as possible, as soon as possible. Ask them to join to the live classes. So listen to the live classes and practice. Whatever I am explaining, compulsory you must practice. Okay, without practicing, so practice makes more stronger, more better, more sharper. right? Yes, so now we are discussing about Ohm's law completed. Ohm's law completed. Next one we are discussing about resistance and resistivity. So resistance will discuss. Resistance and resistivity, it will be included. Okay, so what is meant by resistance and resistor? So what is meant by resistor? What do you mean by resistance? What do you mean by resistor? So what is SI unit of resistance? What is the SI unit of resistance, and what is symbol for resistance? So the phenomena of opposing the electric current is known as resistance. The phenomena of opposing the electric current is known as resistance. SI unit of resistance is ohm. SI unit of resistance is ohm. Okay. SI unit of resistance is ohm. Clear? So resistor is a device. Resistor is a device which is used to oppose the electric current in the circuit. A resistor is the device which is used to oppose the electric current in the circuit. Resistance is the phenomenon of opposing the electric current in the circuit. Resistance is the phenomenon of opposing the electric current in the circuit. Okay. So now you can see R is directly proportional to L. So resistance is directly proportional to length of the conductor. Resistance is inversely proportional to area of the cross section. Resistance is inversely proportional to area of the cross section. So R equal to rho into L by A. Here, rho ke what is rho? Here I don't know about rho. Sir, what is rho? You wrote here rho. What is rho, sir? Resistance is the phenomenon of opposing the electric current. Resistor is a device which is used to oppose electric current. Okay, so I hope it is very clear. Now, resistance is depends on length of the conductor. If you take normal wire, so resistance will be less. If you take long wire, resistance will be more. Else, okay. So normally if you take the pipe, water pipe if you take, so if you at the end, so at starting point of the water, if you press it, automatically the force will increases. If area is increases, so more number of water will be coming. Okay, so no resistance will be there. Yes or no? So like that, if your college gate is there, so if it is less space, only few members will enter at a time. If the gate is very large, then more number of students will enter into the college. Yes or no? Yes, this is also same thing we are discussing now. So if area is less, resistance will be more. If area is more, resistance will be less. Okay, so this is about resistance is directly proportional to length of the conductor. Resistance is inversely proportional to area of the cross section. Area of the cross section. I hope it is very clear. Just check once here. Okay. So now SI unit of resistance is ohm. SI unit of resistance is ohm. Okay. Now resistivity. Resistivity. Resistivity is nothing but, so rho equal to RA by L. Resistivity equal to RA by L. RA by L. What is the SI unit of resistance? Ohm. SI unit of here is meter square. SI unit of length is meter. Meter get cancel. SI unit of resistivity is ohm meter. Ohm meter, very important. So this is for 2 marks. 2 marks. This is for 2 marks. This is for 1 mark. 1 mark. And this is for 1 mark. Definition also will get for 1 mark. Resistance resistivity. Okay, so here, we are discussing about resistance. Resistance is the phenomena of opposing the electric current in the circuit. Resistor is the device which is used to oppose the electric current in the circuit. Resistivity. Rho equal to RA by L. SI unit of resistance is ohm. SI unit of resistivity is ohm meter. SI unit of resistivity is ohmmeter. Ohmmeter. Okay. So I hope it is very clear. So this now we will see. They will ask the difference between resistance and resistivity also. They will ask differences between resistance and resistivity. So resistance depends on length of the conductor, yes or no? Resistance also depends on area of the cross section, yes or no? Are you agree with that? Are you agree with that? Yes or no? Are you agreeing with that or not? Yes. Resistance is directly proportional to length of the conductor. Resistance is inversely proportional to area of the cross section, and resistance is also depends on temperature. Resistance also depends on temperature. Resistance also depends on material of the conductor. Resistance also depends on length of the conductor and material of the conductor. Resistivity depends on temperature and material of the conductor. So here one very important point, resistivity does not depend on physical dimensions. Physical dimensions are nothing but length and area. Length and area. I hope it is very clear, right? Yes. So now let's see here resistance and resistivity. So till now we discussed about electric current. I equal to Q by T. SI unit of electric current is ampere. SI unit of charge is coulomb. SI unit of time is second. The rate of flow of charge is called electric current. The rate of flow of charge is called electric current. Quantization of charge. So charge. So quantization of charge is nothing but, so number of charges are moving in the conductor. Q equal to Ne. On one electron, how much charge is present? 1.6 into 10 power minus 19 coulomb. In 1 coulomb, how many electrons are present? 6.25 into 10 power 18 electrons. In 1 coulomb, 6.25 into 10 power 18 electrons are present. So that is about 1 coulomb. Next one we discussed. Okay. So that is about electrical element, cell, battery, switch, open switch, closed switch, resistor, rheostat, ammeter, voltmeter, bulb, wire joining, wire crossing. So these are elements. Next one, electrical circuit. We discussed about electric circuit. Electric circuit is nothing but a continuous and closed path of an electric circuit. A closed and continuous path of an electric current. A closed and Continuous path of an electric current is known as an electric circuit. So we discussed about it. That is about electric circuit. After that, we discussed about Ohm's law. Ohm's law is nothing but the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it at constant temperature. At constant temperature. At constant temperature. So that we discussed. Next one, metals required. So 4 cells, 1.5 volts each, nichrome wire, ammeter, voltmeter, switch, and so connecting wires. So next circuit diagram, connect 1 cell and 2 cells and 3 cells. Repeat the process for 3 and 4 and measure, observe the readings of ammeter and voltmeter mentioned in the tabular column below. Then, so draw the graph. Ohmic conductors and non-ohmic conductors. Ohmic conductor, the conductors which obey Ohm's law, those are called ohmic conductor. The conductor which does not obey Ohm's law, those are called non-ohmic conductors. So that's enough. That is about Ohm's law. Next one, resistance. Resistance is the phenomenon of opposing the electric current. Resistor is a device which is used to oppose the electric current. That is about resistance. Is directly proportional to length of the conductor, area of the cross section, temperature, material. Resistivity is equal to rho equal to Ra by L. SI unit of resistivity is ohm meter. Ohm meter. Next one, resistors are connected in series combination. Now we are going to discuss about resistors are connected in series combination. Series combination. Series combination. Series combination. Resistors are connected in series combination. So first I am connecting one cell. You are taking here. This is resistor. Resistor. One, 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 one. So three resistors, R1, R2, R3, R1, R2, R3. Okay. Across R1, I'm connecting V1, 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 V1. Across R1, V1. Across R2, V2. Across R2, V2. V2. Across R3, V3. V3, V3, V3. So I am connecting ammeter. So after that, battery, switch. So here I am connecting like this, cell positive terminal, negative terminal. Here current is flowing, positive terminal, negative terminal, positive terminal, negative, positive, negative, positive, negative, positive, negative. Current is flowing, current is flowing, current is flowing through R1, R2, R3. Current is flowing through R1, R2, R3. R1, R2, R3. In series combination. In series combination, current is same. What is different? Potential difference. How can you say it is different? In series combination, current is same. Throughout the circuit, current is passing is same. Potential difference is different because R1, R2, R3, R1, R2, R3, R1, R2, R3, R1, R2, R3. Three resistors are different. That's why V1, V2, V3, V1, V2, V3, V1, V2, V3, V1, V2, V3 are different across V1 across R1, V2 across R2, V3 across R3. Now you can observe here R1, R2, R3, V1, V2, V3. So current is passing the circuit. Current is passing in the circuit. Now potential difference Is equal to I1 equal to I2 equal to I3 equal to Is equal to I1 equal to I2 equal to I3 equal to I. Now potential difference V equal to IR, V equal to IR, V equal to IR. Potential difference from ohms law V equal to IR. V equal to IR. Vs equal to V1 plus V2 plus V3. Vs equal to V1 plus V2 plus V3. Here IRA, IR1, IR2, IR3. Sir, why you wrote only I? What about IS, I1, I2, I3? Here I mentioned over here IS equal to I1 equal to I2 equal to I3 equal to I. That's why I'm writing directly. Now I can take common. I am taking common. I am taking common. I am taking common. I common. I common. R1, R2, R3. I common, you can cancel it. I common, you can cancel it. The remaining value Rs equal to R1 plus R2 plus 3 R3. Rs equal to R1 plus R2 plus R3. Resistors are connected in series combination. Resistors are connected in series combination. R1, R2, R3 across R1, V1, across R2, V2, across R3, V3. So ammeter, voltmeter, current is same, current is same, current is same, current is flowing in the circuit. I1, I1, I2, I3, I equal to same enter the circuit. But Vs equal to V1 plus V2 plus V3. IRS equal to IR1 plus IR2 plus IR3. IRS equal to I am taking common. I am taking common. Remaining values R1 plus R2 plus R3 plus I am cancelling I value, I value, I value, I am cancelling I. So the remaining values I am cancelling. Remaining RS equal to R1 plus R2 plus R3. Rs equal to R1 plus R2 plus R3. If n number of resistors are connected in parallel combination, n number of resistors are connected in parallel combination, combination. If n number of resistors are connected in parallel combination, the formula R is equal to NR. R is equal to NR. R is equal to NR. NR. This is about resistors are connected in series combination. So this is about resistors are connected in series combination. Now, so everyone do like, share and subscribe before going to the next topic. Okay, just to click on like button if you like the channel, if you like my explanation, if you like the content. Okay, so do like, share and subscribe to Student Brand. You can share to your friends. You can ask your friends to join to the class. Share as much as possible. Share as many as possible. Right? So now resistors are connected in parallel combination. 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 So here you can observe. So three resistors are connected in parallel combination. Oh. Three resistors are connected in parallel combination. I1 through R1, I2 to R2, I3 through R3. So here you can observe one thing. The current is dividing into three parts, but potential difference is same. Are you understanding? Did you observe one thing here? Current is dividing into three parts, but potential difference is not dividing. Potential difference is same across R1, R2, R3. Potential difference is same, but current is dividing into three parts. R1, R2, R3. Here from Ohm's law, V equal to IR. V equal to IR. V equal to IR. So we can take Vs. Vp equal to V1 equal to V2 equal to V3 equal to V. So Vp equal to V1 equal to V2 equal to V3, V3, V3. Understood or not? I hope it is very clear. Okay, so now you can observe in this case, so potential difference is same. Yes or no? Potential difference is same. Now current is different. So then IP equal to I1 plus I2 plus I3. Yes or no? Potential difference is same. Same. Potential difference is same. But current is different. 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 Yes. So V by Rp equal to V by R1 plus V by R2 plus V by R3. So I am taking V common. I am taking V common. Shall I take V common? V I am taking common here. So the remaining values are V I am taking common 1 by Rp. V am taking common 1 by R1 plus 1 by R2 plus 1 by R3. So V I am taking common, so that's why we can cancel it. V I am taking, already I took common. So can we cancel it? Can we cancel it V? Because on both sides, left hand side and right hand side, both side V is common. So shall I cancel it? Shall I cancel it? We can cancel, no, we can cancel. We can do it, right? We can do it. We can cancel it, right? We can cancel it. No problem, we can cancel it. Because both side, LHS side or RHS side, both V is common, so we can cancel it, right? I, okay, it is okay if I cancel? Okay, so shall I cancel on both side? So I'm cancelling. Okay, so I'm cancelling on both sides. V I am taking common. I cancelled here. The remaining equation is 1 by Rp equal to 1 by Rp equal to 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. So I hope it is very clear. 1 by Rp equal to 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 1 by R1 plus 1 by R2 plus 1 by R3. That is about resistors are connected in parallel combination. Resistors are connected in parallel combination. So if n number of resistors are connected in parallel combination, if n number of resistors are connected in parallel combination, what is the formula? What is the formula? The formula is 1 by Rb equal to n by R. The formula is 1 by Rp equal to n by R. That is the formula. The formula Rb equal to R by N. Rp equal to R by N. Rp equal to R by N. R by N. What is that? Rp equal to R by N. If n number of resistors are connected in parallel combination, oh my god, you can't able to see that equation. I am writing here 1 by Rp equal to R by N. Rp equal to N by R. N by R. Oh. Rp equal to, okay, sorry. So Rp 1 by 1 by 1 by 1 by. So 1 by Rp equal to N by R, because in the numerators you can see 1. So R by N, Rp equal to R by N. So this is the formula. You can observe here 1 by Rp equal to 1 by Rp. Are you understanding or what? Are you understanding or what? Tell me, let me know. Is it clear or not? So I am saying from that time onwards, you are not listening what I am saying. Because from that time onwards, I am standing and teaching all the concepts. So do you understanding or what? So let me know. Is it clear or not? Is it clear or not? The electric current definition I explained. Electric current definition I explained. Okay, SI unit of electric current, SI unit of charge, SI unit of time. Okay, so quantization of charge. After that, electrical elements, conventional current, electric circuit, resistance, rheostat. After that, we discussed resistors are connected in series combination or resistors connected in parallel combination. Now we conclude that resistors are connected in parallel combination. The final formula is 1 by Rp equal to 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay, that is nothing but if n number of resistors are connected in parallel combination, 1 by Rp equal to n by R. So if Rp equal to R by N. So I hope it is very clear. So now resistors are connected in Parallel combination. Resistors are connected in parallel combination. Heating effect of electric current. Heating effect of electric current. What is heating effect of electric current? The potential difference V equal to W by Q. V equal to W by Q. V equal to W by Q. W equal to VQ. W equal to VQ. Okay, so the potential difference across the ends of the given metal conductor. So that is a difference. Here we are discussing about potential. Okay, electrical potential difference. Work done to bring unit positive charge from one point to another point within the conductor. V equal to W by Q. So W equal to VQ. P equal to rate of doing work. VQ by T. P equal to V into Q by T. Q by T is I. What is the rate of flow of electric current? Rate of flow of charge. Rate of flow of charge is called electric current. Rate of flow of charge is called electric current. Rate of flow of charge is called electric current. P equal to VI. So E equal to P into T. So whatever the energy is given to the conductor, that will become in the form of heat. 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 Okay. So now you can see P equal to VI. P equal to VI into T. What is VI? VI equal to IR. V equal to IR. H equal to IR into I into T. H equal to I square T. Heat produced in the conductor is directly proportional to current. Heat produced in the conductor is directly proportional to resistance. Heat produced in the conductor is directly proportional to time. Yes, so this is about heating effect of electric current. V equal to W by Q, W equal to VQ, P equal to W by T, VQ by T. P Q by T is rate of flow of charge is called electric current. I equal to Q by T. So then P equal to V into Q by T. P equal to VI. Heat produced in the conductor equal to P into T. That is QH energy. So energy, whatever the energy is given, that will become in the form of heat. H equal to Vi into T. V equal to IR. IR into I into T. So then we'll get H equal to I square RT. I square RT. Heat produced in the conductor is directly proportional to square of current. Heat produced in the conductor is directly proportional to resistance. Heat produced in the conductor is directly proportional to time. This is about heating effect of electric current. This is also known as Joule's law of heating. So H equal to I square RT. It is also known as Joule's law of heating. So do like, share and subscribe to Student D Brand. Thank you so much for joining and give. So do like, share and subscribe to Student the Brand. Thank you so much for joining and attending, listening my class. This is our Shiva sir from Student the Brand. Thank you so much for your support. Thank you so much for your constant and what we can say, unmatchable, unbreakable, unthinkable. So all okay. So thank you so much for joining and attending. So just click on like button, share to your friends, ask your friends to join to the class. So subscribe my channel for remaining classes. Thank you so much for joining and attending. This was Shiva sir from Student Brand. So thank you so much for subscribing. Thank you so much for our support. Okay. So I need your support. I need your support for continuous my work. To continue my work, I need your support. Please support me. Please subscribe my channel. Please share to your friends. Ask your friends to join to the class. Click on like button. Okay. So thank you so much for supporting and thank you so much. So doing continuous support. So do the same. This is Shiva sir signing off. Thank you.